Good morning. We will start session 4 on chapter circles. So we completed theorems on chapter circles, that is with respect to chord properties and angle properties. We'll start with an exercise here. We already completed first exercise, which was nothing but fill in the blanks and true or false. The next exercise is again with some type of riders what we have. First one, recall that two circles are congruent if they have same radii. We call that two circles. So two different circles are given here. Two circles are congruent. So given that circle 1 is congruent to circle 2, that means these circles have equal radii. Congruent circles have equal radii. Prove that equal chords of congruent circles. So AB is a chord of one circle, CD is a chord of another circle, subtends equal angles at their center. Now, this is the figure when they have given us two circles. Suppose if only one circle was given, the figure would be something like this. This is center, equal chords, subtend equal angles at the center, right? But here they have given us two circles in the question. We will follow with that respect. So given O and O dash are the centers of two congruent circles, then what else is given? AB and CD are the two equal chords. That is AB is equal to CD. If the circles are congruent, that means OA is equal to OB is equal to OC is equal to OD. Reason are the radii of congruent circles. Now what we have to prove? We have to prove that angle AOB is equal to angle COD. Those will subtend equal angles at the center. Congruency, what we will prove here is proof. In triangle AOB and triangle COD, I can first of all write AB is equal to CD. Chords are equal. Given I will just write because we have already written there. Then can I say OA is equal to OC, OB is equal to OD, OA is equal to O dash C, OB is equal to O dash D. Radii of congruent circle. Which congruency rule here? Triple S. AOB is equal and congruent to triangle CO dash D, because we have used OA is equal to OB, O dash C is equal to O dash D, right? By triple S congruence rule. So from this, can I tell that angle AOB is equal to angle COD CPCD? Hence proved. That is what we had to prove here. Look at the next one, that is a converse actually. Prove that if the chords of the congruent circle subtend equal angle at the center, then the chords are equal. So O and O dash are the centers of the two congruent circle. AB and CD are the chords. That's all. Okay, they are not equal chords, are the chords. They subtend angle. Given angle AOB is equal to angle COD. What we have to prove here? We have to prove that AB is equal to CD. Okay, this we have to prove. Let us do the same thing here in proving part also. These are the radii which will remain same thing. Angle AOB is equal to angle CO'D given. So two sides and one angle. It is nothing by SAS congruence rule. This and this. Therefore, CPCT AB is equal to CPCT. Now, I have done everything adjustment here only, but you have to do this twice. You have to write the first sum, again copy the second question, do it similarly. With that, we complete this exercise. Only two sums. We'll quickly move to the next exercise where only three sums are there. We'll finish that. With that, we can end today's session. So the next exercise, first one, draw different pair of circle. How many points does each pair have in common? So the first pair when I draw, so non-touching circles. Okay, so these are non-touching circles. This is center O dash and this is center O. So no points in common. They do not touch anywhere in common. Second part, we will have touching circles externally. So this is O, this is O dash, they are touching at a point P. So one common point P. Third part, we will have again touching circle, or what we can say here is different pair of circle. How many points does each pair have in common? So touching circles externally, again if I say touching circles internally, like how do they meet or how do they intersect when they talk about? If I have a one more circle here, this is again P, so this is O and this is O dash. Again one common point. That is P. Last what we will have is here intersecting circles. Like this. It will touch at P and Q. This is O and this is O dash. How many common points do they have? Two common points. All the circles which I draw, children, again I am repeating, this should be done neatly with compass with appropriate radius. Two common points P and Q. Very clear? Okay. Next one. Suppose you are given a circle, give a construction to find its center. Now this question, it's like we have to be, a circle is given to us, but we have to find the center of the circle. Now for this what we do is, there is a construction to be written also. That writing construction part I will be sending you on how to write it. Few points, steps for construction, what we say now, that one. Let's see how do we do that. So actually what we are supposed to do here is take a bangle or anything and just have a round circle, right? Now we don't know where is the center of the circle. Now what we will do, we'll just mark 3 points. Random 3 points on the circle here. I will join these points first. I'll mark this as P and Q. I'll also join these points as R. I will bisect this point now. How do I bisect? Take a compass, right? So So we bisect this as, take a compass, take more than half radius, right? Bisect here, bisect here. Similarly with this point you bisect. So you get 2 points for this line PQ, join. Same, got it? Similarly again here QR. Again see that here, bisect this line also. So we get it, join. There is a point where the perpendicular bisectors of the chord PQ and chord QR will meet at one point, and that point is actually the center of the circle. If you want, take your compass, keep it on that point and just see from every point it will be equidistant. That is how we find the center of circle, right? In the construction also same thing. Draw a circle. Mark 3 points on the circumference of circle, join the points and name the chords, what we will write. Draw perpendicular bisectors for the 2 chords. The point where both the perpendicular bisector meet is known as the center of circle. Those steps for construction I will be sending you. I hope this construction is very clear. The next one. Two circles intersect at 2 points. So third one, 2 circles intersect at 2 points. Say these 2 points are A and B with the circle as center O and center P. Okay. If 2 circles intersect at points, 2 points, prove that their centers lie on the perpendicular bisector of the common chord. Now what can be the common chord? If I join AB, AB will become the common chord for both the circle, and if I join this, this will become a point where the common chord will meet. Okay. Now we have to prove that AB is a perpendicular bisector of OP. Or OP is a perpendicular bisector of AB. That is what we have to prove. Given O and P are the centers of 2 circles intersecting at point A and B respectively. To prove, what we have to prove here, OP is the perpendicular bisector of AB. That is OP perpendicular to AB. Construction, join OA, OB, AP and BP. And mark the point M where OP intersects A. This point I will mark this as M. Okay. Proof. Let me take congruency proving now. I choose the triangle. In triangle AOP, and triangle BOP. Okay. First of all, OP is equal to OP. OP is equal to OP. Common side. Now this triangle and this triangle, I can tell OA is equal to OB. OA is equal to OB. Here AP is equal to BP. Reason? Radii of same circle. Therefore, triangle AOP is equal and congruent to triangle BOP by triple S congruence rule. From this, can I tell angle AOP is equal to angle BOP, CP, CT. Therefore, now this AOP, I will read this as AOM. See, if angle AOP is 30 degree, angle AOM will also be 30 degree. I'll just take part of that. Therefore, angle AOM is equal to angle BOM. Right? Keep this as it is. So, shall I rub this, children? I require this now. I will just write and keep here. Angle AOM is equal to angle BOM. Okay? Let me erase this much of part. Choose the smaller triangle now. Second part. That was first part. Write that first part as it is there. In triangle AOM and triangle BOM, I will use the same thing first. Angle AOM is equal to angle BOM. Reason proved above. Okay? OA is equal to, this angle is equal to this. OA is equal to OB. Reason radii of same circle. Then next part, OM is equal to OM. Common side. Which one? SAS. Triangle AOM is equal and congruent to triangle BOM by SAS congruence rule. From this, I will tell that AM is equal to BM. They are bisectors at least, not perpendicular, but at least bisectors. CPCD. Done. And angle AMO is equal to angle BMO. CPCD. Always whenever 90 degree is asked, we know how to do it, right? We know that angle AMO plus angle BMO is equal to 180. Reason linear pair. But AOM is equal to BMO. AMO is equal to BMO. So I will write twice of AMO is equal to 180. Angle AMO is equal to 90. 2 comes here. Therefore, AMO is equal to BMO is equal to 90. If these two are 90, that means I can tell that OP is perpendicular to AB. Hence, proved. Right? Whenever 90 degree is asked, it is done by linear pair only. And to get that linear pair, angles are equal, which is done by CPCD. With this, we complete these two small exercises in today's session. So in tomorrow's session, we will again start with the next exercise, that is next sum riders based on triangle and their chord and angle properties.